The James Webb Space Telescope is a large space telescope that specializes in infrared astronomy. Its state-of-the-art high-resolution and high-sensitivity instruments allow it to observe objects that are too distant, faint or old for other space telescopes like the Hubble Space Telescope. This opens up new frontiers in many areas of astronomy and cosmology, including the study of the first stars, the formation of the first galaxies, and the detailed atmospheric characterization of potentially habitable exoplanets. Before we move ahead, please like the video and subscribe to the channel for more videos like this. The design and development of the James Webb was led by the U.S. National Aeronautics and Space Administration, NASA, which partnered with two other major space agencies, the European Space Agency and the Canadian Space Agency. NASA's Goddard Space Flight Center in Maryland managed the development of the telescope, while the Space Telescope Science Institute in Baltimore, located on the Homewood campus of Johns Hopkins University, currently operates it. The primary contractor for the project was Northrop Grumman. The telescope was named after James E. Webb, who was the administrator of NASA during the Mercury, Gemini, and Apollo programs from 1961 to 1968. James Webb was launched on December 25, 2021, on an Ariane 5 rocket from Kourou, French Guiana, and arrived at the Sun-Earth L2 Lagrange point in January 2022. The first image taken by James Webb was released to the public via a press conference on July 11, 2022. The James Webb Space Telescope is stationed at the second Lagrange point, L2, which is approximately 1.5 million kilometers, 930,000 miles, from Earth. The L2 point is a stable gravitational point in space where the gravitational pull of the Earth and the Sun are balanced, allowing the telescope to remain in a relatively stable orbit while maintaining its position relative to the Earth. This location is also ideal for observing the universe as it is far enough from the Earth to avoid interference from its heat and light, but close enough to allow for communication and servicing missions if necessary. One of the primary advantages of the James Webb over the Hubble telescope is its infrared capability. While the Hubble is capable of observing in the near-ultraviolet, visible, and near-infrared wavelengths, the JWST is optimized for observing in the mid-infrared to the near-infrared range. This means that the James Webb will be able to see through dust and gas clouds that have previously been impenetrable to other telescopes. This will allow astronomers to study the formation of stars and galaxies in greater detail, as well as observe the early universe when the first galaxies were formed. The JWST also has a larger mirror than the Hubble, which will allow it to gather more light and produce sharper images. The Hubble has a mirror that is 2.4 meters in diameter, while the JWST has a mirror that is 6.5 meters in diameter. The larger mirror means that the James Webb will be able to observe fainter objects than the Hubble, and it will be able to produce images with greater detail. The James Webb Space Telescope is equipped with 4 scientific instruments, which allow it to perform a wide range of observations. The Near-Infrared Camera, NIR-CAM, will be the primary imaging instrument, and it is able to observe in the near-infrared and mid-infrared wavelengths. The Mid-Infrared Instrument, MIRI, allows astronomers to study the early universe, as well as the formation of stars and planetary systems. The Fine Guidance Sensor, Near-Infrared Imager and Slitless Spectrograph, FGS, NIRISS, is used to measure the positions and distances of stars and galaxies, as well as detect the presence of exoplanets. Finally, the Near-Infrared Spectrograph, NIR-SPEC, is used to study the chemical composition of stars and galaxies, as well as search for the first galaxies formed after the Big Bang. James Webb has the potential to revolutionize our understanding of the universe in several ways. One of the primary goals of the telescope is to study the formation of galaxies and stars in the early universe. By observing these objects at great distances, astronomers hope to gain insight into the conditions that existed shortly after the Big Bang. The JWST is also to study exoplanets in greater detail than ever before, which could help us to discover whether or not there is life beyond our solar system. The JWST has the potential to make many groundbreaking discoveries in astronomy, but it is not without its challenges. As will be positioned at a location that is much farther from Earth than the Hubble, which means that it will be more difficult to perform maintenance or repairs if something goes wrong. Despite these challenges, the potential of the JWST to revolutionize our understanding of the universe is immense. Its capabilities in observing infrared light and its larger mirror size has allowed us for groundbreaking discoveries in the study of the early universe, galaxy formation, and exoplanets. As technology advances and new discoveries are made, the JWST will play a crucial role in expanding our knowledge of the universe and our place in it. Please don't forget to like and subscribe to the channel. Thanks for watching.